Okay, guys, welcome to the meeting for this week. Welcome back to Dr. Richard Gordon, who had, a health problem that he informed you about via email, and he's been recovering. He's back in good condition. He's on a treadmill today. He's joining us from his working treadmill, so he's going to weigh in on the Bacillaria stuff. And so, welcome back. Okay, so does anyone have any questions that they need to talk about before we get started?
Nothing from my side, sir.
Okay. How about Ujjwal or Paras? Asmit's back. Okay.
Nothing from my side, sir.
Okay.
No.
Okay. Let me see. So this week, what do we have? Someone wants to present, or do we have any updates on the different, Bacillaria? Let's have an update on that first.
Oh yes, sir. We would like to present we have segmented images, and I think our model worked well according to what we have taught, and
Okay.
I would like to show results.
Sure. Share your screen. Okay.
Is my screen visible?
I can see. No, I can't see your screen. It said it was sharing, and then it didn't come up. So try it again.
Oh.
Actually, let me look and see if I have the right one. Yeah, go ahead and share it again. Okay. Keep saying
my screen. Is it visible now?
I think so, yeah. Yeah, I can see it now.
Yeah, so we have some results this is what image we have got through the microscopy. We have converted this image and segmented this image into this kind of boxes where each filament of Bacillaria is being segmented, and we have stored all the features of this Bacillaria bacteria in XML files. So these are so in this process we have used things like we have first created XML records through TensorFlow, and then by using just a minute. Yeah, then by using this code, which is XML to CSV converter, we have converted all records to CSV files, and after that we have trained it on our GPU models, and after training them there, we have got these images which are being segmented. I will very soon upload all the scripts of training as well, which is on my desktop.
Okay.
Moreover that, I have also started writing the neural networks introduction as the Richard have asked, and I have write a lot about it, and I will surely share the draft as soon as it is finalized and completed. It has, as you can see, that it has some errors right now, so I will surely.
But yeah,
So
you've got a
that's
lot
all
there.
about it.
So you're coming along on that. So let's recap and discuss what we have. So the first thing we did was you had a training set that you worked on, and you completed that, and then you used that training set to train a model. In that model, you were able to analyze the data, some of the images, and find individual cells segmented. And then you were able to output that in XML format.
Oh yes, sir. There are some mini steps between them which I am going to explain in my writings, which I am doing right now.
Okay.
So I will like to share all the steps as soon as it is completed.
Okay. And then you also have the write-up that you were showing, which is
Yeah. I have started writing, and it is like it has some errors right now, but I will surely make it perfect, like in grammar and all these things, and I
okay.
will share it with you.
All right. You have a question in the chat. Are all cells regarded as being the same size?
Oh, no, sir. Like we have labeled the cell like around 50 to 80 images. We have labeled them by our hands. So we have like all kind of cells, like different size of cell, which we have labeled by ourselves uh, manually, and based on that labeling, we have converted these results through our machine learning models. So it is not necessary like they all have to be same size.
Okay. What do you? Where did you store your training data set? Are you planning to make that open, or do you have that in a location where people can access it?
So I will upload the training scripts on GitHub. Like it is right now, I'm right now connected through my laptop and it is my desktop.
Okay.
But I will upload it on GitHub.
Okay. Good. Okay. How about Asmit and Paras? Do you have anything to add to the presentation? Any comments?
No, sir, that was it. Ujjwal explained it very well. That was the whole process of it.
How about Asmit?
Oh yes, sir. Like we have XML points of all the cells which has been segmented, and through XML points, I guess so we can write down all the parameters of Bacillaria.
Yeah, that's a question from Richard. It was, can you list sizes of all cells, width, length, coordinates of center, angle? Yeah, so we would want to have like a set of parameters that are outputted.
Right now, I am not sure about angle because I have never done like this. But yes, we have XML coordinates, so we can figure out something.
Yeah. Yeah. Okay. Why are the cells hand labeled?
Actually, so before, if you are training a model in deep labs, so first of all, you have to label some data manually. Like you have to feed that data to the model which you are creating neural network, so that it can learn from that model that what you are being going to segment, and based on that learning, it will automatically segment all our images in an unsupervised manner.
Yeah. So that was part of the training state phase where you would label them and then you'd actually have it find matches in test set where you would wouldn't be labeled but you would find something similar. And then Richard has another question, but can you number cells in the image? Can you number cells on the image in their order in the colony? Not sure what that means.
Left to right.
Oh, so can you? Yeah.
That's all to right.
So if you had, well, like if you saw that image, there's like a stack of
Yeah.
rectangles.
Yes.
Can you like order them in each frame? Because when you take them out of context, because we're collecting data per frame, but we don't know which order they are on the frame. Like, if you have like 7 rectangles stacked next to one another,
They numbered 1 to 7. In the same order that you see in the picture. That's the question.
So that means like we have to number the rectangles which we have in an image.
In the order in which they appear, yes. From one end of the colony to the other.
Okay, sir. Like I will try to modify scripts according to that, and I will let you know if I am able to do that.
Okay, good.
I mean, it's probably a matter of like, I don't know if it's like finding something from like the leftmost cell to the rightmost cell, if you like use the cell centroids, you might be able to do it. But of course, they overlap, so it's a bit tricky. But there might be an easy way to do it just by some, measure that you're already outputting, and just say like if it's, take all these that are in the same frame, in the same image, and order them in some way, and then output like an order. And then you would have like an address. So it would be like each image would have its own order. And so if you go from image to image, you would say, well, this was number 1 in image A, this is now number 1 in image B, and then you can actually track their movement because they have an identity, each cell.
We can put a cap on the distance that each rectangle has traveled, because in one frame, if we have a rectangle at 0, 0, 1, 1, 0 and 1, 1, so we can see how much distance that cell has traveled from one frame to the next frame by saying, by putting how many consecutive. We have trained our model on around 50 to 100 frames, so it works pretty well like on all the frames. So we can run this model simply on all the images we have. So we have around 1,000 to 2,000 images where we have these labeled rectangles, and we can track the movement across these frames.
Yeah. 2,000 consecutive images. So I guess this is in terms of a movie.
Yeah.
Yeah.
Yes, like if we test our model on these images, we'll get labeled images of around like 1,000 to 2,000 for one video. So we can analyze.
Is the number of cells the same in every frame analyzed? Okay.
No, sir, it is not necessary. Like, we have some frames which are so distorted, like it is not even visible to human eyes, like there are some filaments in that. So in that cases, the model just collapsed. So like it varies from cell to image to image.
So I guess I had a question about the. Oh, go ahead.
I just want to say that we have a video where we have a black background and the filaments are very clear. So like also the test images we showed was of the black background. So like for that, I guess our model will work pretty well, and we can analyze around like all the frames we have got from that black background video to see the movement.
I guess I had a question about, like, we were talking on Slack about the different algorithms you were using to segment, and for a while you were getting like a result where you were getting the edges were really fuzzy. You couldn't really lock onto the edges. And these images look a lot better in terms of like the boundaries. They're a lot sharper, and they seem to pick up a lot more of the detail, at least in terms of the filament boundary and like distinguishing between background and the actual boundary. So what was it that you found that made it much sharper like that? Was it just switching over to like a training, using a training set, or what is the?
So earlier the models we had used were like they were OpenCV on like they were not exactly machine learning models. They were simply mathematical models that see the state of the image as it is, and then like they grayscale it and see the difference between the intensity of the pixels. But here we use entirely different thing, which is like pre-made model by Google, which is Deep Lab V3. Like this is already trained on so many like it's pre-trained. So we have to use transfer learning. That is like we have to change the last layer of that model. So all of the work is being done by that pre-trained model. We are just feeding the model some training data of around 100 or 50 images, and then like it learns really well on that only to show such results.
Okay.
So like we have majorly moved from simply identifying the difference between the identifying the boundaries on basis of intensities to deep learning. So that was.
And by deep learning, you mean like learning like what the boundary should look like and then generalizing it to
Yeah,
different
so
boundaries.
like
Yeah.
our training set had, so like we have an image with these rectangle, like the test image we got. We other our training images were similar, so we just took random 50 images from the videos and labeled by hand using a tool, labeling such rectangles, and we then feed them to the model. So the model will train on the XML files which have the coordinates of these rectangles. So now it will want, like given similar images, it will now predict these boxes on the new image based on the on learning on the training images. So like that's why we're getting rectangles like that.
Okay. There's another question from Richard. Please plot number of cells versus frame number. This would identify portions of a movie that could be reliably analyzed. So that would just be like once you get the number of once you get the identity of the cells. So we'd have like this, the frame number and the cell number in the frame ordered. Then we could take, we could just basically take each frame and see how many cells we have in a frame. So it's a count of how many number of cells are in that frame. And then we could plot it out to see like what I guess it's, he wants to see what parts of the movie do we have enough cells in so that we can track them across frames. Because, I mean, they move around in and out of the frame. So I don't know, like, that's one way you could do that, is just simply produce a plot, a
Yeah,
bivariate plot. Yeah.
we'll have to run this model on the whole video, like around 100 images for 10 second, I guess 10 or 15 second video, and then we can see like which part is performing good, on which part the model is performing good, and then we can choose that. But like I was saying, I hope that the images with black background will perform much better than others, because others were blurry and this one like has clear boundaries in terms of filaments.
Right. So, I mean, yeah, so part of that, and I mean, I don't know, because they do move in and out of the frame, so it's, the numbering should be consistent if they move back and forth. But if they start twisting around, that may be a problem. But I think, the first step there is just to say, like, to go through the video and see if the results, maybe we can track one cell and see if it's, follows a reasonable path. If we go back to the movie and look at it, and then look, we can plot the points for each, like cell number one in each frame. Does it follow what the movie looks like? And then we can plot that out. We can also do like an aggregate count. So I mean, those are ways we can validate the actual output. Sir, like how many consecutive images do you think we need to track to get the parameters? Well, I mean, you would have what do you mean parameters, like for each cell, or in field of view overlapping would change the number of cells identified? I guess I don't know what you mean, but like, so we'd have like, because we're outputting parameters for each cell in each frame, but then you'd have like over a large number of frames, you'd have all these data that would say like it's cell 1 in image 1, cell 1 in image 2, and so forth. And what we want to do is we want to be able to validate the actual, cell order and everything, so that we at least make sure, first of all, that because they move around and sometimes they move back and forth, sometimes they kind of change their orientation. So we want to be able to take those output parameters and actually plot them in like a bivariate graph or something, and then look at the trend and then look at the movies, like just go back and validate and make sure that it's tracking everything. Now, in terms of like if you get to a point where some of the cells are kind of, they're, oblique, because, you're taking microscopy images, but the specimen moves with respect to the plane of view, so it's not perfect. It's not like you're watching something move on a two-dimensional sheet of paper, it, on a flat way, it can twist and bend, and it's, there are ways in which it moves that may not be able to be detected by the algorithm. So that's why we want to do a lot of this validation stuff. But in terms of, like the basic parameters like size and that sort of stuff, that would be on every cell. I guess I don't understand your question beyond that, but if they're overlapping, yeah, you might not be able to detect individual cells. Richard says, I'm trying to come up with a criterion for whether a movie is worth detailed analysis. Yeah, I mean, it's, and some of the movies that we have aren't very good in terms of, like, if we plug it into something that we can train the model on, but maybe the way it's, the quality of the image, because you have a lot of algae moving around in front of the filaments, or the filaments move. I guess what Ujjwal was saying was that the filaments move, and then, as they move, you might not be able to get the boundaries quite right. Yeah, so we'll have to work on that a little bit more, I think. But I think to start, we should just get the parameters and maybe make some plots, some summary plots, and just look at those trends and then look at the movies and say, does this make sense? Do the data make sense, at least in terms of, like, reconstructing the motion or the position? It's not going to be perfect, and there might be some false positives in there, but I think, and I don't know what it would be worth, you say, what parts of the movie be worth analyzing. I mean, I don't know. We could even impute values for areas where we have, some ambiguity. So, I mean, that's not entirely like, I mean, it's a technique you can use to get around that, but I don't know. We'll see when we get when we can plot some actual data, what it looks like. So, I mean, I think you guys are definitely on the right track. I think this is very good work. If we have maybe next step is, like I said, run the algorithm through, actually collect some data from the algorithm, have it analyze some images, and then let's just play with the data and see what happens. One criterion for how constant size parameters for a given cell are across frames. Yeah, so I mean, we can do things like look at the constant, like, we can look at how the data change over frames. I mean, again, the algorithm is going to pick up stuff, it should be systematic, though. I mean, it shouldn't be like, you should be able to detect whether it's picking up the right things or not, basically. Because we're talking about, a model, and we're talking about, like, a machine learning model that's generalizing a training set. So we're training it on these, rectangles, basically, and we're saying pick something that looks like this. And it'll pick the objects out of the image, and it'll do it in a way that's not like stereo, it doesn't have to be exactly like it. It can be a little bit different, maybe a little bit bigger, maybe a little bit different shape, but it'll detect it and it'll say, okay, this is an object. But the thing is it could pick up, like, I think we'll see maybe in some of Vinay's work, it'll pick up things in the background that look like it too. And so we can't be absolutely sure that we're going to get what you showed us in the picture that you put on your screen share, Ujjwal. Yeah, subtle point. If width of a cell increases, it may be dividing. Okay, yeah, and so there are a lot of things there that are going to maybe wreak havoc on this in certain parts of the movie, like that. And I don't mean wreak havoc, it's just that we're going to have to think about how to deal with that. So should leaders see both daughter cells? So yeah, I mean, there are going to be probably parts of the movie where we're going to have a lot of ambiguity. And then we'll deal with that when we get to it, because I think there might be some interesting methods for sort of, figuring out, we can identify, first of all, we can identify outliers or things that don't look correct. Like if you have like a dividing cell it might not be detected, it might be out of sequence. And so then we can focus on those things. And, there might be ways to train it to just identify those things. So we can go back through the images and find those things and then combine the data together. This is like we're going to have to maybe get a little bit creative in terms of the machine learning application here. I don't know. Well, we'll see. But the next step for you guys is just to kind of get some data and let's kind of, the first step of reconstructing the organism is to plot the data just to see if it makes any sense at all. If you can see, if it looks like the movie. If there's a sequence of movement, for example, it spirals around and then you see that in the movie, then you have a pretty good chance that it's picking up on a real feature. So are there any other questions? Ujjwal, Asmit, Paras, do you have any comments on this?
So we will try to do whatever is being discussed in this meeting, and we will try to show you the results as soon as possible.
Okay, how do you guys feel about it? Do you think it's going? Do you think you're headed in the right? Do you feel comfortable with the direction it's headed in?
We can plot the graph as discussed, but I am not sure about we have to develop some mathematical models to find out angles and all these things. It is not like we can just put some very easy subtraction and multiplication and we can find it. We have to do some maths on it.
Yeah.
So I think it will take some time.
Oh yeah, that's good. You can have you're trying to calculate polar coordinates and it's a little bit tricky, but I'm just curious as to if you find it to be, if you're comfortable with how the work is coming out. Do you think you'd be able to do the angles? Is that a thing that is achievable?
We will try to do all this analysis in the coming weeks, and I think we are more comfortable in telling whether we can do it or not after 1 week, when we try actually on the model.
Okay. Yeah, I just wanted to get a sense of how you guys were doing in terms of the technical aspect. So that sounds good, though. It sounds like you're coming along. Good. So that's good. So why don't we move on to Vinay and his project? Richard said if you have a rectangle, angle is just trigonometry. So you can there are a lot of shortcuts to getting angles from data. You can use the motion between 2 frames or 3 frames to figure out, to find an angle just by finding, whether it forms some sort of triangle, and then use trigonometry. But, yeah, there are a lot of tricks there. We'll talk about it later, though. So, Vinay, how's your project going? We were talking in Slack earlier this week about your progress, and I brought up the case that you showed me about the background noise.
Yes, sir. Regarding that, you suggested about using those centroids and finding the distances between the blobs and find out which red colored blob is farthest from the rest. That was the approach, right?
Yeah, we talked about how it was identifying background blobs as cells, and then we were talking about how to get around that, and then I mentioned the thing about finding basically determining it to be an outlier in the embryo. So if you have a bunch of cells and the blob is way out here, you can use distances between the centroids of those cells to sort of say this is an outlier.
Yes, sir. Regarding that approach, I tried to again find out the centroids and of each of the blob. But before that, I wanted to finish this plugin development, writing the code for the plugin.
Okay.
So this past week, I imported the TensorFlow models into D24J. I was able to get the results, and I was able to say the image, like output image, the segmented image to the disk. So what happened is that there's a slight problem over there. Again, the issue came from the deep learning for J side. So basically, they have in Python they have NumPy arrays, right? Like multi-dimensional arrays.
Yeah.
So in deep learning for J, they have something like IND arrays, like which are analogous to NumPy arrays from NumPy. So basically, what I wanted to do is that I wanted to convert this IND array, which is the output image from my model, to a buffered image. Like it's a Java class which enables us to write the image to the disk. So basically, they did not have any functionality which can directly convert a 3D image like an RGB image to a buffered image. So I had to find out some workarounds for that. So what I did is that basically I converted that IND array into a matrix of double values or float values. It doesn't matter for float or double. So again, from that matrix, I converted that matrix into a image. So the slight problem is that when I'm converting the matrix to an image, there's a slight disturbance that is coming. Like some values are getting maybe like distorted kind of things. So I'll have to deal with that just for that. Apart from that, I see a clear way. Like I don't see any other problems. Maybe I'll be able to fix that soon, like in a day or two, and then I will be done with this plugin. I will be complete. I can complete this plugin and I can share it with the community.
Oh, good. Yeah, that sounds good. So you did find a way to do that, and it's pretty straightforward. Okay, that sounds
Yes, sir.
good.
Like I said, there's a yeah. Thanks.
All right.
That's the only thing for this week, and all the other things are like there. I think by Sunday I'll be able to push the complete code and also the documentation how to use the plugin.
Okay, that sounds good. Yeah. Okay, yeah, that sounds good.
Yes,
I
sir.
also wanted to point out that coming up this next week, and I'll remind you in the newsletter, we have second evaluations for GSOC. So I'll be doing yours, and then I think you have a
Yes, sir.
second
Yeah.
evaluation. So they're getting really they're getting really kind of nervous about students coming too close to the deadline. So I don't know. But anyways, so why don't we actually let me go back to the chat. We have a couple more things going on here. Okay, so Ujjwal responded to Richard, but sir, these are rectangles in the image. For analysis, we have XML files with some coordinates. We need to make sense of it. It's very nice in visualization, but quite tricky to process. So that's something that we can work on. We may need to do another step of being able to take the XML output and creating like a CSV file, so we can have a output for data. Just basically, we need to output the data. We need like some sort of dump that allows us to just get the numbers. Yeah. So I mean that's how we'll work with the data. That's a different step here, is working with the data to process it. It should actually be. I mean, I can work with you guys. It'll make it a lot easier. So then Richard asked, did any of you start drafting a manuscript? Ujjwal said that yeah, he did show that document, and he hasn't made it public yet. But that's going to be basically, I guess people were starting to do the method, make sure the methods are nailed down, and then I have yet to get a full manuscript drafted. But I think once we have the methods, it'll come a little bit easier to get everything organized into a manuscript. But yeah, we've been, while Richard's been gone, we've been discussing that a little bit about how we would do the manuscript. I thought we'd start with the methods first, so that's what Ujjwal was showing, and so that we'll just eventually Ujjwal I want you guys to push the document to GitHub. We'll just do it there, and we can edit it, at least, parts like the methods. And then we can assemble it in Google Docs later. But, so, why don't we go to the boards now? So the first board is, we'll start with Vinay's board. And this is the repository here.
Yes, sir.
And if we go into that repository, we'll go to the projects, and then we'll go to the board, which is the Summer of Code project. And we have our issues here. We have in progress and to do. So in progress, we have a couple of things. We have test output images with k-means clustering. Is that done, or is that, because I think it's probably done.
Yes, sir, it's done.
Okay. Yeah, that was what you were showing me last week. So, oh great, I'm not in the right account. Okay, so can you move 26 to done for me? I think you can do it.
Yes, sir, sure.
Okay.
Yeah.
All right, thanks. Next one, conclusion of plugin development, scheduling additional time for enhancement.
Yeah, like I said, I'll be done with the plugin development hopefully by the in a day or two, and then we can discuss how to. We can discuss more on how to deal with the outliers.
Okay.
I think it should be
Leave that in progress.
for a couple of days.
And then build a plugin. So that's probably done. Number 13. Can you move that over to done?
Yes, sir. Sure.
All right. And then begin work on semi-supervised approach, number 17.
So, like that's after this plugin development that I can go to that, right?
Yeah.
I think that should be also in progress.
Okay, so we'll leave that in progress.
You share your screen so I can see what you're doing, what you're reading.
Sure.
Thanks.
Let me see. Present entire screen. Can you see it now? Okay, so we're on this board here. So let's go to the to-do column. So we have determined a method for identifying noisy outlier regions. So we number 27.
Yeah, I think we need to get. I think we need to bring that into in progress and change the title to implement.
Okay, move it over there, and then can you
Can you
change the
Yeah.
All right.
Yes, sir.
And then to change the name, you just click on the issue and then edit the title.
Okay.
So if you go right here, you click on it, and then you go in and
I updated, so can you see the change?
it hasn't updated yet, but I mean, I can do it later. It's fine. So let's see. Then number 15, DevoWorm and Neuroinformatics outreach. That is to do. I mean, that's open.
Yeah.
You know. Segmenting bright field images, number 11. Yes. That's also open. Well, that's for phase 3.
Yeah.
So, do we have any new issues that we need to add to the board?
No, nothing. I think I'm on track, and I think I came very close to completing the plugin. Yeah.
Okay. So then once we get the plugin done, then we'll be going to work on the noisy outlier regions issue. And then after that, then we'll talk about that probably at next week's meeting. So very good. I think that's good. So let's now move on to the next board. This is the digital Bacillaria board. And I'm going to be at a similar handicap with this board because I don't have I'm not in the account right now. But this is the link to the repository. And then we go to Digital Bacillaria, we go to Projects tab, and then we go to the Digital Bacillaria board. And now we have our issues here. We have in progress and to do. So if one of you guys, Ujjwal, Asmit, or Paras can move the issues around when I say move them, that would be good. So we'll start with in progress. Number 37, acquire results for training set. So is that done?
Yes, sir. Training is I think complete.
Okay, can you move it over to done? Thank you. Now we have welcome to Paras, Mehan. This is a presentation. Do you want to do a presentation or?
So actually, I couldn't find time to find a good paper. So I'm looking into it. I'll let you know next week or so.
Okay, leave that in progress. Mathematical model development number 27. So this is a little tricky because now we're talking about mathematical models for the Bacillaria itself, and we're actually talking also about mathematical models for validating the results. So why don't we leave this in progress? Maybe you'll think about this a bit more, how we might split this issue up, depending on how you guys want to approach maybe we should add an issue on, and I'll add it later when I think about how to phrase it, but add an issue on, like, basically working with the data, with the output data. So maybe working with output data, like validation. Like you said, maybe if we could get it outputted from, we have the XML files, but maybe get like outputted as a CSV file as well. So we have like everything is comma delimited, and then from there you can import it into something like Excel or into Python, where you can actually do some analysis. Okay, so we'll talk about that later. But so number 17 then, adding information about the biology of Bacillaria. That's kind of still open. Description of neural networks approach for biologists. I think that's probably what we were getting at with the methods, so that's in progress too. Number 31. Template methods, number 29. Ujjwal was showing us his methods that he's working out, and so that'll be, you'll use that as a template for all your methods. You'll kind of there'll be a lot of repetition in terms of the format. So, you'll have a section for each little piece of detail that you do. So if you do something apply some technique, you want to write a description of what you did and maybe a little bit about how it works, because we're trying to appeal to a broader audience than just machine learning people. So we want to have a little bit of description in there, but I'll work with you on the editing that text as well. So, and then number 30 is review. Okay. Number 30 is review Sambuku, which is the paper that I shared with you from one of Richard's collaborators. That's the paper. It's like on diatoms. It's a more general paper on diatoms, And that's just basically for you to read over and like kind of model your methods after that. So, don't think you have to don't think you have to master the paper. Just kind of look at the method section, and it seems like that's what you're doing, but we'll talk about that more later. Issue number 35 is labeling data set. So I think this is done, isn't it?
Yes, sir.
Okay, can you move it over to done, number 35?
Yes, sir.
Thank you. And then model evaluation. And this is still ongoing. This, I think, is what we're talking about when we're talking about, building a bivariate graph of the points that are generated by your output. And so that's in progress, of course, but we'll probably create some issues around that because right now it's still like kind of vague as to how we're going to do that. But I think that's a good way to like kind of get a handle on what we have, what we can get, and then reconstruction is not easy. Just to let you know right now. It might take a couple passes and maybe use a couple different training sets to actually get a lot, all of the information out. So, but I think we're headed in the right direction. So to do is we have a couple of issues. One is model features within and between frames, and then we kind of talked about that a little bit so far. We'll leave that in to do, and let me make a note about number 28. We might create a couple of issues around this as well, sort of around 7 and 28, because we're talking now about like getting multiple frames and tracking between frames. And so I think we have a little bit better idea of what that's going to look like. Create video resources for Bacillaria biology. That's open. I don't know if anyone has any ideas about that, but you can, it's open. If anyone has any ideas, we'll discuss them. And then define features within and between frames. So actually 3 and 28 are linked. I think defining the features within and between frames might be a case of where we have the data and then we plot the data out in maybe a graph, or we model it in some way. We actually find that there are certain features that like maybe characteristic movements or curves, but that's after we get the data out and we can really analyze it. And like I said, I want to be in the loop on once we get the data out, I will help you go through. In fact, we might actually do it in a meeting where we kind of walk through the data a little bit and plot things out, and like we can really get a handle on what's there. So I think that's something that maybe we'll do in the next few weeks whenever we're ready for that. Whenever we can have a data set outputted that's just numbers and that represents a large number of frames, and we can actually track the cells so we have the identification number and everything. So, but we'll do that in the next few weeks. So anyone have any other issues they want to add to the board? I mentioned that we were going to, I was going to add some later, but anything we want to add right now?
So defining features and plotting graphs, I think these are all under sub-issues of defining model features. So I think we don't need any issue for now.
All right. Yeah. I was just thinking about breaking that up, so it's probably that issue is probably a couple of steps. So I want to make sure that we kind of take it one step at a time and we kind of address them independently. But it's also if we just go ahead and do it and then find that we address all these issues at once, that's fine too. But yeah, so if anyone has any ideas for issues over the course of the week, you have the power to put them into the board, as you've seen your power to move issues around. So I encourage you, if you have a good idea of what you want to accomplish with something and you think it deserves an issue, put it on the board. And that goes for Vinay too. You can do that as well. So let's stop sharing that. So if that's it for the boards, then I think we're on track for this week. Does anyone else have any other issues or questions they want to raise?
Nothing from my side, sir.
Okay. All right, Asmit says none. Okay.
No, sir.
Okay. Richard, are you? Okay, good. Looks great. Thank you. All right, everyone. Well, thank you for attending the meeting. And I look forward to your discussion this week, over the course of the week, on different things. If you want to talk in Slack or email, let me know. If we want to get, if we have an issue that comes up or we have an idea of something we want to kind of, add to the mix, let's communicate about that. Otherwise, we'll see you next week. I might be a little late to the meeting next week. I have a prior meeting earlier in the day, but I hope to be here on time. But if I can't make it on time, I'll let you know. It'll just be a delay of about 30 minutes or so. So everyone have a good week, and talk to you guys later. Okay, thanks.